In this question, the graph shows the variation with time of the speed of the ball from the instant it is released until it impacts the ground. So the y-axis is velocity, x-axis is time, and we need to find the value of area under the curve. And the curve or the graph is shown in this figure. And how do we find the area under the curve? First, we need to identify that region whose area we are supposed to find. Step number one, we go to the extreme of the graph, which is this point, and we will draw a dotted line passing through this point, and that dotted line needs to be perpendicular to the x-axis, and that line will look like this line connects the extreme of the graph and it is perpendicular to the x-axis. So the region between the graph, this red line, and the x-axis, this region in the middle, that is the area which we are supposed to find. Now there are various ways to find out the value of this area. I am going to explain you first the easy way and then the traditional, which is the longer approach. But since this question is just a one marker, we should use a method which requires the least amount of time. So here we go. Method number one. Now focus on this entire graph. Of course, this is not a straight line. So what we can do is, if I draw a tangent at this point at the origin, the tangent will look like this. And if I draw a tangent at this point, the tangent will look like this. Incidentally, this tangent is horizontal. And now, if you consider this trapezium, which is made up of x-axis, this vertical line, this horizontal line, and this slanted red line. If we are able to find the area of that trapezium and subtract the area which is not required, and what is that area? This entire shaded region we need to subtract from that trapezium. So let me repeat. First, we will find the area of the trapezium and then we'll try to subtract this shaded region. That will give us the right value of the area under the curve. So let us try to identify the area of this trapezium. So how do we do it? We will divide this trapezium into two parts. First will be a triangle. So this region is a right angle triangle and this second part is a rectangle. Let's try to find the area of this triangle. Base of this triangle is 1 units and the height of this triangle, if you observe carefully, it is 9.5 units. So let's write down the area of the triangle first. It is half base into height, half multiplied by 1 multiplied by height, which is 9.5. And if we solve this, we will get the value of 4.75. Hence, the area of this right angle triangle is 4.75. Now, coming to this big rectangle, what is the base length of this rectangle? Now, coming to this big rectangle, the base of this rectangle we need to identify first. So this point is 1 and the point over here is 3.6. So what will be the length of the base of the rectangle? It will be 3.6 minus 1, which comes out as 2.6. So base is 2.6 and the height of this rectangle is again 9.5. So let's write down the area of the rectangle, which is base into height. Base is 2.6 multiplied by the height is 9.5. And if we simplify this, we get the area as 24.7. So what will be the total area of the trapezium? We need to add the area of triangle and the area of the rectangle. So if we add these two numbers, let's write down the area of the trapezium will be 4.75 plus 24.7, which is equal to 29.45. But that is not the value which we require. We need the area under the curve, which is given in the figure, and we have identified the area of the trapezium. All we need to do is just subtract the area of this shaded region. But the problem is this shaded region is neither a triangle nor a rectangle. In fact, it is not any general shape. That is why it is difficult to find the area of this shaded region. So how do we find the area of this? That is where we are going to use approximation. Now, since this question is just a one marker, we can very well use approximation. So how do we do it? We will try to create a rectangle in this figure whose area is approximately equal to the area of this shaded region. Now consider this small rectangle which I have drawn. So basically we are using basic common sense and logic. We have drawn a rectangle whose area is approximately equal to this shaded region. So let's try to identify the area of this rectangle. So this point is 1 and this point over here, the coordinates will be 1.6 comma 0. So let's identify the base length of this rectangle. So the base will be 1.6 minus 1, which is 0.6. So base is 0.6 and the height of this rectangle is 2. So on the top, let me write down the area of this small rectangle will be 0.6 multiplied by 2, which gives us 3.2. Now, to get to the exact answer, the value of area under the curve, we need to subtract 3.2 from the total area of the trapezium, which means the answer should be 29.45 minus 3.2. And if we simplify this, we will get 26.25. And now we can write down the value of area under the curve is 26.25 units. And you will get full marks for 26.25. Now, bear in mind, since we have used approximation, that is why the examiners have a pretty wide range. If your answer can fall in that range, they are going to give us full marks. And look at the range which is mentioned in the marking scheme. If your answer lies between 25 to 31, that is enough to get 1 mark. So this was the first method, which is the faster method. Method number two. In that method, we will have to identify the number of squares which are there under the graph. And let's try to solve the same question using the method number two. Step one remains the same. From the extreme point of the graph, we need to draw a line which is perpendicular to the x-axis. And then we have to find the area between the graph, this red line and the x-axis. So how will we do that? If you try to actually count the number of squares, it will of course take a very long time. So what we'll do, we'll divide the entire region into various types of figures. So for example, if I consider this big rectangle which is inside this graph, now please watch, if I have drawn this rectangle, it is a little outside the graph also. So this part of the region where my cursor is, we don't need that area. But since we are approximating, we can ignore this area. And why I have created this big rectangle? Because I can just add one more rectangle on the right hand side like this. So if we can identify the value of this area, then we'll just multiply it by 2. With these two big rectangles, we have covered majority of the area. Now the remaining region is also to be focused on. Now let's try to create a small rectangle here. So this purple rectangle which I've drawn, and then let us put more such rectangles one over another like this. So as you can see, there are 1, 2, 3, 4 purple rectangles all placed vertically. And now let us try to fit as many purple rectangles as we can in this figure. So over here, we can fit one more purple rectangle. And on top of it, we can fit one more purple rectangle. So how many purple rectangles are there? Let's count. 1, 2, 3, 4, 5, 6. So all we need to do is find the area of the small purple rectangle and then just multiply it by 6. Now let us try to focus on the remaining region. If I think of another big rectangle like this, so by now you might have realized we are actually trying to fit as many rectangles as we can in this figure. So on the top, if we consider one more green rectangle like this, or if we draw another rectangle over here, we are trying to cover as much area as possible. Now, still some areas are left. So, for example, this particular region, let's start from the origin up till this point. So, this entire region can be approximated to be a right angle triangle. And then this small little area also can be considered a rectangle. This region also considered a rectangle. And this region also considered one more rectangle. And that is how step by step we will cover the entire area of the graph and we'll get the value of area under the curve. Now in the exam situation, of course, this approach is going to take a lot of time. But since the question is just a one marker, that is why we use the shortcut method one. If we use this method, our answer will be more accurate, but accuracy is not required for this question. Because in the marking scheme, if your answer lies in this broad range, you are going to get full marks. And that is why I try to prefer that method one, which is the shortcut which I had described.